Multiflash 7.2 has new modelling features geared for petroleum and reservoir engineers. In this video, you will see what they are and how you can benefit from using them. The set of standard PVT experiments now includes the slim tube experiment. It joins the multiple contact and swelling test experiments that debuted in Multiflash 7. After characterising and tuning the fluid, reservoir and petroleum engineers can easily simulate the effect of gas injection on the reservoir fluid phase behaviour and compare with the experimental data. With the addition of the slim tube experiment, reservoir engineers can now graphically evaluate the minimum miscibility pressure so they can establish the most suitable gas injection rate and pressure for optimal oil recovery. Changes in reporting capabilities make it easy to generate reports. After simulating or regressing a set of PVT experiments, Multiflash allows you to generate a full report in Microsoft Excel format of the whole dataset, including experimental points, simulated results and deviations. Now you can create full PVT modelling reports of the most relevant data and experiments with just one click. Reservoir fluid contamination with drilling oil-based mud can alter the phase behaviour of the sampled fluid. However, as the well produces, OBM ejects and the produced fluid becomes progressively cleaned. This phenomenon may result in a produced fluid exhibiting phase behaviour and physical properties potentially very different from the initially contaminated sample. The mud cleaning tool in Multiflash now allows you to numerically separate the mud from the reservoir fluid, even in absence of mud composition or estimated mud content. You can now automatically estimate mud composition or the level of mud contamination using an algorithm. This allows reservoir and petroleum engineers to perform sensitivity analysis and predict the phase behaviour and physical properties of the cleaned fluid with little or no information. Fluid characterisation may be done several times at different stages of a project. The characterisation with a common set of petroleum fractions is very useful to limit the number of components. This is important when modelling large fluid sets commingling in transport or processing. However, simultaneous characterisation of all the fluids sometimes is impractical. For instance, when a new well or reservoir is brought into production at a later stage, the recharacterisation of the whole set of fluids may be necessary to keep consistency. Multiflash 7.2 now allows you to add a new fluid to a fluid set originally characterised with common pseudo-components. By loading the existing file with common fractions, you can add one or more fluids to the collection and recharacterise without modifying the properties of the existing components. This gives you more flexibility to the characterisation process and allows you to keep consistency across the fluid description. The lack of consistency of fluid modelling across disciplines is potentially a major source of errors in design and operations. Although various disciplines may have different requirements in terms of fluid description details and properties, the ability to maintain a minimum consistency level for phase behaviour and fluid physical properties predictions greatly contributes to a project's success. For this reason, the Multiflash connectivity with other tools continuously expands. In this release, you can export the fluid to Eclipse either for compositional or black oil simulations. This allows petroleum and flow assurance engineers to characterise and tune fluids with the appropriate detail level for their purposes using Multiflash. They can then export them, maintaining prediction accuracy and consistent physical properties, to reservoir engineers involved in designing and operating production and transport facilities.